Hello folks, this is Dr. Mughal here. Um, so we're gonna start lecture 5 today. Symbolic numbers, variables, and expressions, equations. Previously we had done plotting, we did array creation, and we went through several commands in lecture number 4 where we uh, learned how to create array using random integers or just whole numbers, and what different commands that we can use to create random matrices. For example, trace, magic, I, zeros, ones. And we also learned how could we do the multi-dimensional array. We also did some matrix operation, basic addition, multiplication, subtraction, and division. We also did some transpose diagonals, and here were a few different commands that I wanted you to do on your own. This should help you to find out the maximum number in an array or a minimum number, or sort them in ascending or descending order. And here was 2 examples at the end. We are going to follow part of this lecture, and then we are going to apply some of the things that we have learned from lecture 4, and then carry it forward to lecture 5. In lecture 5, we will be dealing with equations that would have symbols. For these symbols could be, or variables could be, x, y, and z. These not necessarily may have any value, but we will use equations and then solve it simultaneously and find out the parameters for x, y, or z, or whatever variable, depending upon the equation, the complexity of the equation. So let's start. You're going to start with complex equations first. I got few equations in there. This is basically 3 squared minus 5 plus 4 in parentheses divided by 2 plus 6 times 3. So this is basic calculation, and this equation has power, addition, division, and multiplication. Similarly, if you move on to the second one, b equals to 4 to the power 3 plus 5 times 4 in parentheses minus 1 plus 2 over 3. So in this equation, we are doing the power as well, addition, multiplication, subtraction, and division as well. So these, sort of equations should help you to do calculation on some of the complex equation. Similarly, x equals a sine of -1. When you have a here, this basically means inverse, sine inverse. Similarly, a cos would mean cos inverse. So let's go and put these equations in a script file in MATLAB. Just like we usually do, open a new script file, save it right away. So I'll save it lecture 5. Go again, start with your name, project name. Make sure you have this percentage sign. This means it's a comment and it's not a part of the program. I'll just copy it from here and then paste it over here. And then today's date is 2017, 16th of June. Okay, we'll start with complex equations. So complex equations, and the first equation we got is a equals to 3 to the power 2. So if you notice, here's my work directory, here's my script file, here's my command window, and here's my workspace variable, and I was working a little here. So I already got 3 variables, a and s, and b here. So I would like to clear them. So what you could do is either go here and say clear, or you can do it over here, clear all. This would mean it would erase all the variables here. Okay, Also, one thing, I don't know if I mentioned this earlier or not, but if you look at this ANS3, so for example, if I am doing some math here, let's say 4 plus 3, and I have not really assigned a variable to this equation. So by default, the answer will be saved in a variable ANS. So for example, if I enter here, by default, the answer would be saved in a variable ANS. However, if I say A equals to 4 plus 3, then the answer would be saved in a variable A. Okay, so it's always important to clear all these variables before you start your program. Okay, so the first equation we got 3 square. So variable name A, 3 square. We always use this hat sign. 3 square minus 5 plus 4 in parentheses, minus 5 plus 4 in parentheses, divided by 2, plus 6 times 3, plus 6 times 3. Okay, make sure you save it as you go. Let me run this equation and see what I get. Evaluate selection. So I get 22.5. Okay, and if I run this file, you'll see it cleared all the variables which were there, and this A is basically this equation right here. Okay, all right, let's move to the next one. Next equation is 4 power 3 plus 5 times 4 minus 1 plus 2 over 3 equals to 4 to the power 3 plus 5 times 4 minus 1 plus 2 over 3. 2 over 3. Let's go ahead and save it and execute this line, and we get 83.6. You know, sweet. Then the next equation we got is x equals to sine inverse of -1. So let's see, I'll use variable c here, and then we have a here, a sine. Remember, this a is not this variable a is a sine is a sine inverse -1, and this basically takes basically returns you with sine inverse of -1. Okay, let's see what we get. Right click, evaluate, -1.5708. Okay. A couple of commands that we learned in the previous lectures. Format long. So if I execute this line again, evaluate, you see it will give you up to 15 decimal digits up after the decimal points. Okay, format long. But if you say format short, I believe it will take you to up to 5 decimal point. Yeah, 1, 2, 3. Yeah, and then basically rounding off this number, 5708. Okay, so that's the difference. So I'll just keep it format long, depending upon what are you using it for. I like to keep it long. Okay, let's move it to the next equation. Y equals to cos inverse of -1. D equals to a cosine of -1. Again, this returns you with the cosine inverse of -1. Right click, evaluate selection, 3.1415. Okay, let's move to the next one. x1 equals to x squared minus square root x times y. I know I keep on changing the variable names, but it is up to you whether you want to change it or not. But I just like to go from A to Z. Okay, E here equals to x squared. X is my C, so C squared minus, if you are trying to take a square root, we use command sqrt, square root of x times y. X is C, y is D, so I make it C times D. Save. Let's see, what do I get here? Right click, evaluate selection. 2.4674 minus 2.2214. So this is the real part and this is the imaginary part. Since we were taking square root, and you know square root always returns a positive and a negative value, so you got this iota right here. Let's move to another, this right here. Y1 equals to cosine of x squared minus y squared. Say f equals to cosine of c squared minus d squared. Okay, so simple equations, just put them in MATLAB, and MATLAB will do the rest. 0.4356. Let's move to another one. Square root of 3 over 4 plus I over 2. Remember, this I is not a variable name, it's the iota. Okay, you can either use I or J, like I previously told you. So Z, I'll use a variable name G, equals to square root of 3 over 4 QRT, that's the command for square root, 3 over 4 plus I over 2. Okay, let's go ahead and run this as well. Here's the answer, 0.866 plus 0.5 I. Okay, let's now move to the next part of today's lecture, which is the symbolic expression in variables. One thing that you should notice here is I got these variables here, 3, 4, 5, 6, 7, 8 variables here. And if I say variable A and enter in the command window, it returns me the value for variable A. Similarly, if I type G in the command window and press enter, it basically returns me the value that I have in the workspace variable for variable G. If I say H and I press enter, MATLAB would give me an error because it's an undefined function and that variable actually do not exist in the workspace. In addition, there may be, there may be an equation where you have variable name, but those variables do not have any value assigned to it. So for that, we use the command sim. So I tell you what is the purpose of using sim command. Okay, sim command, exact representation of data unlike the floating point. So sims x, shortcut for constructing symbolic variables. I have an equation, s equals to x squared over x. We know if we do the math on it, x will cancel out with one of the x in the denominator and the answer would be x. But before we can do calculation like this, we need to make sure that we are defining the x as a symbol. Okay, otherwise if we don't do it, it will return you with an error. So I say sims x, okay, and then I do the calculation, s equals to x squared over x. S equals to x squared over x. Okay, and let me do this, execute this line, right click, evaluate selection. Okay, now it says undefined function of variable x here because I have not selected this line. Let me select this line as well now. and hopefully it should not give me an error now. Okay, there you go, s equals to x. Whereas when I did not select this line and I was only trying to execute, MATLAB thought this x has some value which has not been defined by the user. So it is really important that we use this command before we solve any symbolic expressions or equation that may have any variables which don't have any defined value. Okay, similarly, x power 4 divided by x power 2, which means x squared would cancel out with 2 of the x's, and then we would be left with 2 of the x in the numerator. So that would be s equals to x squared. So s equals to x to the power 4 divided by x to the power 2. And let me execute this as well. There you go. S is equals to x squared now. Okay, let's move. B is equal to sim 4 over 5. Let's see what this does. Okay, and also if you have more than two or three, one variable, for example, you got x and y, you can always say x, y, or z. We will do some examples which would have more than one variable. Okay, b equals to sim 4 or 5. Let's see what this does. Let me change the variable name here. H equals to sim 4 over 5. Okay, let me go ahead and execute this command and see what happens. Okay, this sim command is basically give you the exact representation of how you would put a value for a variable. Okay, if I don't put sim here and I execute this line, it would still give me the answer, which would be the right answer, but the answer would be in decimal point. If I like my answer to be in fraction, it has to be, I have to use sim command. Okay, this is one of the uses of the sim command here. And then I have sim 5 over 6, I equals to sim 5 over 6. Again, it's basically doing nothing except for displaying the exact representation of the data the way it is in the code. And then we have sim b plus d. Basically, we are adding these two variables, and we would like it to be the way it is right here. So j equals to h plus I, and then obviously we want the exact representation. Sim, save. Let me select these 3 lines and right click, evaluate selection. So adding 4 over 5 plus 5 over 6 would give you 49 over 30. And if you take the LCM right here, 6 times 5 is 30, and 5 times 5 is 25, and 4 times 6 is 24. 24 is 49. 49 over 30. Okay. Okay, let's move to the next equation we got. Okay, this time we are making a matrix. Looks like it is a 1 by 3 matrix. So we got 1 column, second column, third column, and fourth column. Actually 1 by 4. So let's do this. Y equals to, let me go with the variable name k equals to. Okay, the first element in the matrix is sim 11 over 21. Sim 11 over 21. You should know what does that mean now. It's basically, that's how in fraction it's gonna displayed in a fraction form in the command window. Sim 5 over 6, 5 over 6, and then 20 and pi. MATLAB knows what pi is. This is 4 by 1 sorry, 1 by 4 matrix. Okay, another one, L equals to, this matrix has 4 elements as well, 1 row and 4 columns, 4, 6, 1 over 2, sim 1 over 2, sim 3 over 4, 3 over 4, bracket close. Let's go ahead and run these two commands. Let's see what we get. Okay, this is the L, 1 row, 4 columns, K, 11 over 21, 5 over 6, 20, and pi. Okay, so sweet. Answer y plus z, y plus z. So K plus L. So I'm going to use variable name M equals to K plus L. And let's see how things look like after this. Basically, I'm adding these two right here. Evaluate selection. Here you go. 95 over 21, 35 over 6, 41 over 2, pi plus 3 over 4. There you go. Okay, double answer. So we are going to learn another command here. And I say double. And obviously I changed the variable name from ANS to M. So I say M here. Let's see what this does. Evaluate. Hey, we got the answer in decimal form. Whereas over here, it was in the matrix form, in the fraction form. And the reason this answer is stored in ANS is because I did not define the variable name here. If I say n equals to double in parenthesis m, that would mean the answer would be stored in variable n. So if I right click, evaluate selection again, this time it is stored in n. Okay, 1 row, 4 columns, 1, 2, 3, 4. Okay, alrighty. I would let you do this one. This is just one equation. Phi equals to 1 plus square root of sim 5 over 2, and then followed by there's another equation right here, which is basically is a function of this right here. Okay, a solving equation. Okay, let's solving equation. So we have this equation, solve. Basically, we have the equation x squared minus 2x minus 4 equals to 0. And we have to find the value of the x. How would we put this equation in MATLAB and find out the value for the x? It's very simple. And let me show you. Okay, again, x does not have any value there. So I have to say that this is a symbol, sims x. Okay. Then I've used the command solve and then bracket parenthesis open in a single inverted comma. You put the equation in there and then followed by a comma and then the variable for which you are trying to find the values. Obviously you got x here, so this has to be x. If this was y squared minus 2y minus 4, then this would have been y. So solve in parenthesis and single inverted comma x squared minus 2x, 2 times x, minus 4 equals to 0. That's the equation, single inverted comma, comma, solving for the x, bracket close, semicolon. That's it. Save. Let's run this and see what we get. Obviously, we will get 2 values here, because the power here is 2. So we get 2 values for the x. One is 5 to the power 1 over 2 plus 1. 1 minus 5 to the power 1 over 2. Basically, under root 5 plus 1, 1 minus under root 5. And again, it's save the value in a variable ANS since I didn't define it. All right, what I did here now, I have added O here because I wanted to store the two values for the X in variable O. So I say O equals to solve and go ahead and save it. Make sure you select these two lines, right click and say evaluate selection. This time the values under root 5 plus 1 and another value 1 minus under root 5 are stored in variable O. If you want to have these values in a decimal form, then what you do is you do I'll use a variable again, O e equals to double for decimal of O. And let's go ahead and execute this command right here now. There you go. And the reason it's so long is because you got the format long. Again, if I change the format to short, sorry, format, yes, finally I got it right. Okay, format short, and I do this again, it only gives me 4 decimal point. Okay, basically it rounds off the fifth digit. Okay, let's go back here. Okay, there's another equation we got. X squared minus x minus 6 equals to 0. This is the equation that was given to you. You have to solve it for the value of x. Again, you make sure you have this sims x, so I don't have to do it again because I'm going to use the same variable. PQ equals to, I use the command solve, bracket open, x squared minus x minus 6, x squared minus x minus 6 equals to 0. 0. Equation is complete, solving it for the value of x. So you say x bracket close parenthesis. Okay, save it. Let's go ahead and run this. Evaluate selection. Here's the value for the q. Obviously the x has the power 2, so it should return with the two values for the x. One is 3, one is -2. Okay, and if you like to store these values in two different variables, you can also do that. For example, you say x1 is equals to q of 1. Q of 1 mean the q variable, it is a sort of like a matrix. It's a 2 by 1 matrix, 2 rows and 1 column. This is the first element of q and this is the second element of q. So you're saying x1 equals to q of 1, meaning 3. So if I press enter here, that means x1 is 3 and x2 is equals to q of 2. So x1 is 3 and x2 is -2. So you can also do that here. Okay, let's move to the next equation. Here the equation is sine of x equals to 1 over 2. Okay, all right. Sine of x equals to, again, forgot to use this command solve, bracket open, sine of x equals to 1 over 2. Obviously I gotta have this single word comma, 1 over 2 comma x. There you go. Let's see, what do we get now? There we go. R is pi over 6 and 5 times pi over 6. Okay, alrighty, here is a little complex equation. This time we have been given two equations. The first equation is is x squared minus y equals to 2. Second equation is y minus 2 times x equals to 5. We have to solve it for x and y using those two equations. Now, first thing, we have to symbolize these variables here. Here, x and y. So x is already here. Maybe I can add y here. Okay. And then s equals to now notice here that we have to find out the value for x and y. What you could do is also make variables here, so that obviously you will get the value for x and y here. The value for the x will go into variable x, the value for the y will go into variable y. So they have gone with x and y. I'll just go with s and t equals to, again we use the command solve, bracket open, in a single inverted comma. Let's put the first equation in there. First equation is x squared minus y equals to 2. X squared minus y equals to 2, comma. Let's put the second equation in a single inverted comma. Second equation, y squared, y minus 2x equals to 5. Y minus 2x equals to 5, comma. Bracket close. Bracket close. Solving for x and y. Sweet. Okay, let's now run this command here. Line. Evaluate. Alrighty. So that's what we were expecting. Two values each for x and y. Here is the value for s. Here is the value for t. Or you can also say x values are stored in s and y values are stored in t variable. Okay, so don't get confused with the variable name. These are just variable name. You can just pick any variable that you like. I'm just following the pattern from A to Z. Okay, next equation. Here is the next equation. X plus 2y is equals to negative 3z. Okay, again, the equation given here, x plus 2y is equals to negative 3z. Remember, there are three variables here, three symbolic variables here, x, y, and z. So the first thing we need to do here is to define our symbols. So I got x, y already defined. I'm going to define z symbol here. And then we used the command solve. If you want to save the answer in some variable, you can go with u equals to solve. Let's put the equation in a single inverted comma again. X plus 2y, x plus 2y equals to negative 3z, equals to negative 3z. Make sure you have these sterics in there. Okay, if you don't put the steric, it will return you with an error. No, so it looks like it's red, so there's something that I'm missing. It's probably this single inverted comma. So once you do that, it should go purple or violet. Okay, again, now we have to tell MATLAB what are we solving it for. Are we looking for the value of x here? Are we looking for the value of y here, or are we looking for the value of z here? Looks like they are trying to solve it for y. Solving it for y. Okay. Okay, and then we want the answer to be display in decimal point. Okay, we'll get to that later. First, we get the answer first. Okay, we are solving it for y, so we say y. Remember, we were solving it for x here, so we had x here. But this time we are solving it for y, so I say y. If you were solving it for z, then I would replace y with z. Okay, let's go ahead and save it. Right click, u, here it is. Y is equals to negative x squared minus 3z over 2. Pretty simple. The value for y is stored in u, which is negative x over 2 minus 3z over 2. Now we would like it to be in decimal point. So again, what we do is we say v equals to double, and since the answer is stored in u, so I say double u. Okay, save it. Obviously we don't need a negative sign there. Okay, evaluate. So looks like it has returned with an error. Okay, so they wanted us to solve it for y, which we did. Use the VPA command to display answer in decimal point. Help VPA. Here it is. So it's basically a variable precision arithmetic, kind of what double does. The only reason the double command is not going to work here is because if you see u has a value which is where is u? Okay, yeah, u has a value which is negative x over 2 minus 3z over 2. Since x does not has any value here, z does not has any value here, so we cannot use double command. Instead, we can use this VPA. Okay, and to use it, it's very simple. You just use VPA, and in parentheses you type the equation where the variable name in which the equation is saved. So that's why I went for v equals to VPA u. So let me select the code, right click, evaluate selection, and here it is. V equals to negative 0.5. Here it was negative x squared minus 3z over 2. We wanted to convert this into decimal point. So negative 0.5x minus 3 over 2 is 1.5 times z. So useful, very useful. Okay, a pretty answer. Let's see what pretty does. Pretty. Again, the answer is stored in v. So I say v. And let's see what this does. Pretty command. Let's say if I do pretty here, pretty actually just makes things pretty. So, and that's why we call it pretty. Here you go. Minus x over 2 minus 3z over 2. Obviously it was not showing here because the answer was in decimal point, but if the answer is in fraction like it was and it was stored in u, it will basically display it like this. Okay, so for example, if we go with something like this, pretty r here, let's say how this would look like. Here you go. Pi over 6 and 5 pi over 6. Similarly, if I do pretty O here and I select this, here it is square root 5 plus 1, 1 minus square root 5. Okay, so pretty will not work here because we have already converted to a decimal point, but it will work on fractions. Okay, let's now move on to non-linear equations. Non-linear equations. Let's close this. Okay, let's see what equation we got. Okay, these are the conditional equations where we have two equations: x squared plus y squared equals to 20, y is equals to x squared, x is greater than 0, and y is greater than 0, and we have to solve it for x and y. Okay, so how would we put this in there? Again, when we have two equations, we would like to save the value for those variables in a variable x and y, or these could be any. Okay, so let me say we u v w and x equals to solve. Okay, and then bracket open, single inverted comma, first equation. First equation is x squared plus y squared equals to 20. Okay, x squared plus y squared equals to 20. Remember, when you are doing non-linear equations where you have been given these conditions, x greater than 0, y greater than 0, you always use 2 equals to sign right next to each other. Okay, so this is our first equation, comma, this is our second equation, y equals to x squared, comma, y, the syntax is little changed but not whole a lot, comma, y equals to x squared, comma, the equations for x and y, the conditions x greater than 0, y greater than 0, invert comma to close the equation, comma, you are solving it for x and y, so you say x and y in a single inverted comma. So first equation, x squared plus y squared equals 20. X squared plus y squared equals to 20, comma, second equation, y is equal to x squared, y equals to x squared, comma, x greater than 0, comma, y greater than 0. This is all we have been given. So invert comma, comma, solving it for x, solving it for y, bracket close, semicolon. Semicolon just means it's the end of the line. Okay, let's run it. Evaluate. Okay, here you go. Here's the answer. W is equals to 2, x is equals to 4. In other words, basically x is 2 and y is 4. Okay. All right. Very, very simple. Okay, how about computing roots of the polynomial? So you have been given this equation right here, x cubed minus 7x squared plus 40x minus 34. You have to find out the roots. Okay. Obviously the power is 3, so it should return us with the 3 answers. One for x1, x2, and x3. So how would you compute the roots of the polynomial equation? So here is how you would do it. You look for the coefficients in the equation. Okay, so x cubed has a coefficient 1, 7x squared has a coefficient -7, 40x has a coefficient 40, and then you have -34, which is the last coefficient in the equation. Okay, so once you have this equation, how would you put this equation into MATLAB to find out the roots of the polynomial? I go here, I'm going to choose variable wxy equals to, bracket open, the coefficient for the first variable, x cube 1, space. You can either use space or you can use a comma like I have over here. It's up to you. 7x squared -7 space 40x +40, and then -34 space -34, bracket close, z is equals to, we use the command roots here, and we say roots of y because the coefficients are stored in y. Here it is. Okay, let's save it and let's run it. Obviously this is a different topic, so polynomial roots. Okay, let's save it, run this. Right click and say evaluate selection. Here you go. Here are 3 values for the x. x1 equals to 3 plus 5i, x2 equals to 3 minus 5i, x3 is equal to 1 plus I. Okay, So here it is. You have calculated the polynomial roots. Let's look at one more equation. Again, we are trying to find out the computing roots of the polynomial. We have 5x4 plus 3x cubed plus 10x minus 25 equals to 0. Okay, so 5, 3, 10, 25. x4, x3. Now notice here, you got x4 here, you got x cubed here, x square is missing. X square is missing, that means that is going to be 0. That's why I have 0 here. x4, the coefficient for x4 is 5, so I got 5 here. The coefficient for x cubed is 3, so I got 3 here. X square is missing, that means I'll have 0 here. And then x is 10, the coefficient for x is 10, so this should be 10 here. Yeah, this should be 10 here. There's an error here. And then this should be negative 25 instead of negative 34. Okay, let's do that. AA equals to brackets, square brackets, coefficient 5, 3, 0, 10, 5, 3, 0, 10, and negative 25. Negative 25. Okay, and then we use the command roots of AA. Okay, obviously we have x, the exponent is 4, that means it should return 4 values for x. Right click, evaluate selection, and here are all those 4 values here. Okay, so very simple. Okay, let's move to the function, computing the result of function for a certain value. So far we have been solving for the equations for x and y. How about if when we solve it for those, we have been given a certain value for x and y, how would we put those values in equation and find out the value for a function? So we have been given a value x squared plus x plus 1. We want to find out the value for a function when x is 1 or x is 4. So if x is 1, this would mean 1 power 2 would be 1 plus 1, 2, 2 plus 1, 3. So f of 1 would be basically 3. Okay, how would we do that? For that we use a command inline. Okay, all right, I'm going to use a variable name in which I'm going to store the answer. AC equals to inline bracket open single inverted comma. Let's put the equation in there. X squared plus x plus 1. X square plus x plus 1 single inverted comma, and then comma, solving it for x, bracket close. You got the equation in there. Now you want to say f of 1. You're trying to find out the value for this equation, for this function, when x is 1. So AC of 1. This basically means AC is this equation right here. When I put the value of 1, that means x would be replaced with 1 in this equation. It should return a value, and like we calculated, should come out as 3. So let's see, there you go, 3. Replacing x with 1 here, 1 plus 1, 2, 2 plus 1 is 3. Let's try one more equation. Yeah, here it is. Or maybe same equation, change the value of x. Let's go with a value of x equals to 4 here. So AC 4 here. Let's see what we get here. 21. Let's verify we get the right answer. 4 to the power 2. 4 times 4 is 16. 16 plus 4 is 20. 20 plus 1 is 21, and that's what we get here. Okay. Here is a little complex equation in which we have two variables, two symbols, x and y. So equation is x squared plus y plus x plus 1. and we are trying to solve it for x equals to 1 and y equals to 2. So how would we do? The first thing we need to do is to put the equation in there. That's what we are going to do. A of d equals to, use the command inline, single word comma, let's put the equation in there. X squared times y plus x plus 1, and we are solving it for x and y. There you go. Now we need to put the value here. I'm going to store the values in variable AE equals to AD. For the x, I want to go with the value of 1. So I say 1, comma, y with the value of 2. There you go. Let's execute this command. Let's see what do we get here. Evaluate. Okay, AE is equal to 4 because we put x equals to 1, y is equals to 2. So 1 times 2 is 2. 2 times 2 is 4. Oh, sorry. 1 power 2 is 1. 1 times 2 is 2. 2 plus 1 is 3. And 3 plus 1 is 4. So you get 4 here. Okay. Okay, character strings here. We are almost getting to the end of this lecture. So what if you want to save a string of characters or a text in a variable? How would you do it? All you have to do is just put it in a single inverted comma. That's it. So this is character strings, percentage character strings. So for example, you say AF equals to hello world. Anything that is in these single inverted commas would appear as a text. So if I run this command, evaluate, you'll see hello world. AF equals to hello world. Okay. Or if you want to say my name James Bond, so you can say my underscore name equals to James Bond. You can have spaces between them as long as it is within the single word comma, it'll work. Or you say you are right. Okay. So my underscore text equals to you are. Okay, one thing that I wanted to mention here, and notice you can also write you are as u single inverted comma and then re. But MATLAB would, if you use only one single inverted comma, MATLAB would think that you have basically finished your sentence, because everything has to be in a single inverted comma. So therefore you replace it with 2 consecutive single inverted comma. That would means the sentence has not yet completed. Okay, it completes basically here with a single. So you are right. Sentence complete, single inverted comma, semicolon. Okay. If the text includes a single code, use 2 single quotes within the definition. That's what we just did. And also here, what we did, basically you can combine the 2 texts together, So far we had been using variable name in which we have a numeric value, and then we would add them or subtract them, divide them, or perform any, arithmetic operation. With the text, you can combine 2 texts together. So they're using a variable statement here, which is a variable name. So I can go with the same variable name statement equals to, then square brackets, they say my underscore name, comma, and then single word comma, they have this hyphen, comma, and then they have my underscore text, So our hope is, if I run this line right here, my name is basically James Bond, so it should say James Bond and single inverted comma hyphen. That would mean this would appear as it is. You know, if I replace this hyphen with a dot, then the dot would appear as it is. So James Bond hyphen, my text is you are right. So let's go and right click, evaluate selection. James Bond, you are right. Now let's say I want to have space after D and before Y here. So what I could do here is have one character space here and then one character space here. Save and then run it back again. Right click and say evaluate selection. Is notice there is a gap now, you know. Okay, so something to make note of. Okay, there's one example here. Basically, we are trying to convert a temperature that's given in Fahrenheit into centigrade. And we would like to display the answer in a string format, in a string of characters. So for that, we use one command, which is number to string or integer to string. You can use any one of these commands. They both do the same thing. So this is number to string. Okay, we have given the temperature. Frequency is not frequency, Fahrenheit temperature 71 here. This is the temperature in degree Fahrenheit. Okay, we know C is equals to F minus 32 over 1.8. Okay, we just converted the degree Fahrenheit in centigrade, and then we would like to temperature text to display the temperature in centigrade in a string of characters. So we say temperature is bracket, square bracket open, very similar to this right here. Temperature is single word comma close, which means this would appear as is num to string comma num to string, because remember this is a number, right? And also I made an error. This should not be in caps, it should be small f, because I have small f here. So whatever the number is stored here, we are trying to convert this number into a string of characters so that we can complete the sentence. Num to string stored in C. Okay, and then we want to have degree centigrade. Yeah, bracket close. Oh, it has to be a square bracket, semicolon. Make sure everything looks good. Save it. So our hope is when I run this command right here, temperature is, this should be displayed as is because it's in a single word comma. Temperature is, and then whatever the temperature it is, it should convert into a string. Temperature is XYZ degree centigrade, because again this is in a single word comma. So I right click and I say evaluate selection. So I say temperature is 21.66667 degrees centigrade. I would like to have a space after is, and I would like to have a space before degree. So go here and I say space, and here also I give a space, one character space. Save, and I run this command again, right click and say evaluate selection. Here you go. Okay, if you want to have a period here, you can also have a period here. There you go. There you go. Okay. Okay, symbolic matrices. I'm not actually gonna go over this because this is very similar to what we were doing here. Okay, so I want you to finish this. Solving system of algebraic equations. Um, this is also similar to the one we did right here, the nonlinear equations. So here's one more example. I would like you to go over it. Um, let's now look over the linear equations now. Okay, yeah, so linear equations. We have been given an equation, x plus 2y equals to 4, 3x plus 4y equals to 5. We have to solve it for x and y. So I showed you there is a way, if we do it like this, we can solve it, but there's another way we can solve it. So it's really up to you. Either you want to do it this way, solving for x and y, we have done it previously, or you want to do it this way. It's really up to you. You're gonna get the same answer. Okay, so I would leave that up to you. So if you want to do it this way, what you have to do, you have to take the parameters, basically the coefficient of the variables, and put them in a matrix form. For example, take the coefficient for the left hand side of the equation for these two equations. So I create a variable. I say a equals to 1. First row we got 1 and 2, right? So I say 1 and 2. Square bracket again, 1, 2. Second row, we have 3 and 4. We are looking at the left hand side of the equation, okay? 3 and 4. So we got 3 and 4 here. 3, 4. Okay. Let's now take the values of the coefficient and store them in B on the right hand side of the equation. We got 4 and we got 5. So we got 4 and 5. In the first row we got 4. In the second row we got 5. Okay. Alrighty. Solution. Inverse. So we are solving it for x and y. Okay. You know that if this is A and this is B, then A times x and y would equals to B, which would mean the inverse of A times B would give you the value of x. Okay, so it's like so you get A matrix here, A times x in the first row, and then you got the y in the second row equals to C here. If you, I basically put this equation into a matrix form. So this is A here, the coefficient 1, 2, 3, and 4. A is 1, 2, and 3, 4. Times multiplied by x and y, So if I multiply this equation, this matrix form with x and y, I get x plus 2y, and 3x plus 4y, times x and y equals to C, equals to B, where B is 4 and 5. We have to find out this x and y, which means we take A to the right hand side of the equation. So this becomes x, y equals to inverse of A times B. And so if I execute this, it should give me the x and y. Okay, this is what we are doing here. So I'm going to use a variable named solution here, inverse of A times B. Okay, let's say I use C here. C equals to inverse of A times B. Save it. Let's run it. There you go. -3 and 3.5 here. Also, let me show you how you can get the same thing done with the the way we did earlier using this example right here. Okay, so I would go back here. My equations were obviously we are trying to solve it for for x and y, so I need two variables. I'll just use the same variable x comma y. The values will be stored in this variable equals to, we use the command solve, bracket open, single word comma, first equation, x plus 2y equals to 4, x plus 2y equals to 4, comma, second equation, 3x plus 4y equals to 5, 3x plus 4y equals to 5, bracket in single word comma, bracket close. Again, I need a single word comma here as well. Yeah, remember that these x and y are symbolic variables, so again you have to define that these are sims x and y. Save it, and then so initially we got c equals to inverse a times b. This is basically this is x equals to -3 and y is equals to 3.5, and we should expect the same answer doing it this way as well. Okay, alrighty, let's run this. Right click, evaluate selection. Here you go, -3 and 7/2. Again, 7/2 is 3.5. Okay. So two ways of doing it. It's up to you, whichever way you want to do it. Okay, unless I mention in there which way I would like you to do it. Try these as well. These are the same ways. There are different ways of doing it, but you get the same answer. Remember, in a MATLAB you can get things done in many different ways, so I'm trying to expose you to different ways things can be done, and then it's really up to you whichever you want to do it. This is the last part on this lecture. Again, what we have to do is we have to basically what we are looking for is finding the values for x, y, and z. We have to find out the values for x, y, and z, and these are the three equations that have been given to us. So let's put these equation in a matrix form like here. Okay, so x has a coefficient 1, 7, and -2, row 1, 1, 7, -2, and then you have 1, 1, 1, 1, 1, 1, and third row you got 3, 2, -1, 3, 2, -1, and then you got b, which is 2, 14, and -9. Right hand side of the equation, the coefficients 2, 14, 9, and then solve a comma b. This command should give us the values for x, y, and z. So let's put it in there. Equations to matrix. So I'll just copy it from here and paste it over here. I already showed you how do I get these. It really depends upon the equation. Let's go ahead and save it. Select your code, right click, and say evaluate selection. Here's your x, here's your y, here's your z. If you want to put these in a variable, so maybe you can say x equals to answer 1. That's the first element. Y is equals to answer 2, because it got stored in ANS because I did not define any variable here. And then you can say z equals to third element in answer, and then you right click and then say evaluate selection. Here you go. This is your x, this is your z, this is your x, and this is your y. Okay, so here it is from lecture 5, and I'll be back with the next lecture.